so incredibly cold. And this actually takes place on rockets. When we launch our ELVs, or expendable launch vehicles, they have ice that can form on the bottom of the rocket. Are you guys going out to the Saturn V Center today? Excellent. So when you go to see it, there's a really cool movie of a Saturn V launch out there. And when it launches, you're sitting in these seats and the whole room starts to rattle. And you see this stuff, white stuff falling off the rocket. It's ice. And that's why the ice forms. It's the same principle here, because we use cryogenic fuels inside our rockets. Okay? So I wanted to show you that for multiple reasons there. So now my balloon's back to its original shape, pretty much. And every now and then my balloon does pop. So not because of cold or anything, because of the balloon can only be elastic for so long. So we'll put that down very gently so it doesn't pop.
Very cool.
And the liquid nitrogen I'm going to put away now, only because it is potentially hazardous. Now, we talked a lot about the temperature extremes, and we said space can be really dangerous because of the temperature extremes. Another thing we haven't talked about yet, and it's another danger of space, is the fact that the vacuum of space means that there's no air out there. Now, we all know we need air to breathe, right? But what most people don't realize is that if there's no air pressure. And every square inch of your body has 14.7 pounds per square inch of air pushing on it. And that's normal for us because we're born here on Earth and we've evolved in this environment. But if you were to take away that air, a funny thing would happen to our bodies. Okay? And let me make you think about the opposite extreme. Let's say you could go to the bottom of the ocean 2 miles down. What would happen to your body from the weight of the water, that water pressure? Yes?
It would crush you?
It would crush you, exactly. To give you an idea of just how heavy water is, every 33 feet of water is equal to 1 atmosphere of air pressure. So all of the air here on Earth pushing down on us, it takes 33 feet of water to do the same thing. So water is very heavy and has a lot of pressure. Now out in space, you have the opposite extreme. You have no air, no water, nothing pushing on our bodies. So I need a helper. Who wants to help me out? Who did I pick last time, a guy or a girl?
Girl.
I picked a girl, so I need to pick a guy to be fair, don't I? How about right here? You're going to come on up? Come on up and help me.
No.
All right, what we're going to do now is talk about air pressure. The astronauts, when they go out in their spacesuits, the spacesuits are pressurized. And I'll talk about what that is in a second. And so are all of our spacecraft that we send astronauts out, and they're all pressurized. Just like an airplane. Have you ever been on an airplane when they say the cabin's pressurized? Same type of thing, because the further up in the atmosphere you go, the less air pushing on you, so they have to pressurize that cabin. So, we'll show you what happens out in space. What's your name? Come over here. I'm going to have you hold the balloon for me. And would you say the temperature is hot, cold, or about room temperature? So, you think it's a little hot? Feel that again. What do you think? About room temperature, right? It's not really hot. Maybe slightly more because your hands are holding, but this is room temperature about, right? All right, so come right here, because as soon as I take the balloon out, I want you to feel the temperature again. And what I want to show you guys is when I place this balloon, which by the way, I have it tied off. It's a closed system, meaning I'm not adding or taking anything away from that. I'm going to put the balloon in here. I'm going to turn the pump on, and the pump has this little attachment hose here, and it's going to remove the air from the chamber here. We call this a vacuum chamber because it simulates what it's like out in space. So turn it on. I'm going to hold it up so you guys can see. What do you notice is happening to that balloon? It's getting huge. It's getting bigger. What happens is air moves from high to low pressure. So when you remove the air from the chamber, you lower the pressure. Now the pressure inside the balloon is greater. It starts to expand. All right? Now watch what happens when I let the air back in. The air All right, so that's